Okay, so I'm still on the Unit 0 practice test, and I'm starting with question number 9. Alright, when I have 1 gram sample of limestone dissolved in acid, I produce 0.3 grams of carbon dioxide. If the rock has no other calcium carbonate, what was the percent by mass of limestone? So I need to figure out how much calcium carbonate I should be able to make from this amount of carbon dioxide, or produce when I figure out how much calcium carbonate generates this much carbon dioxide, and then from there I can figure out the mass using this actual yield. Okay, so I'm going to start with my balance equation. Okay, so I have calcium carbonate, and I'm going to make calcium oxide and CO2. Okay, and that's balanced. So if I have 0.3 grams, 0.38 grams of carbon dioxide, what I know is carbon dioxide's molar mass is 44 grams of CO2 is 1 mole of CO2. Let me see. 16 and 16 is 32 plus 12. Yes, 44. And for 1 mole of CO2, I get 1 mole of calcium, requires 1 mole of calcium carbonate, and 1 mole of calcium carbonate. Calcium is 40, carbon is 12, 3 oxygens is 48, that adds up to 100, which is why we often see this compound used in multiple choice, because it's good for mental math, because I end up with 100 of that, 100 grams of calcium carbonate. Okay, so let's see what we can cancel out. So alright, so if I just look at this, I have 0.38 times 100, it's 38/44, which is not 100%. It's certainly more than half, a lot more than half, so it's greater than 51. And 38/44 is going to give me about a little less than a gram, right? So let's say it's, I don't know, it's 0.9 or so of a gram. And if I started with a 1 gram sample, I'm going to want something that is close to 90%. And the only thing that comes close is 86%. So that's going to be your answer. Alright, for number 10 says, what volume of distilled water should be added to 10 milliliters of 6 molar HCl in order to prep 0.5 molar HCl? Okay, so this is a dilution. M1V1 equals M2V2. Now, one of the words that's circled here says added. Okay, so what I need to remember is that I want to know what I'm adding to the 10 milliliters, not what my total final volume is. Alright, so I'm going to take 10 milliliters times 6 molar equals M2 is 0.5 molar times the volume that I'm trying to find. So if I divide this by 0.5 and this by, that will give me the volume, right? So this gives me 60 over 0.5, which is 60 over 1/2, which is 60 times 2, which is 120. So that is the volume of my dilute solution total, but it says how much do I have to add? So if I'm starting with 10 milliliters already in there, I only add 110 milliliters more. So the answer is B. Alright, I have a 20 milliliter sample of potassium carbonate, 30 milliliters of 0.4 molar barium nitrate. Barium carbonate precipitates, and what's the concentration of barium plus 2 in solution after the reaction? Alright, so this is a pretty complicated problem. Always need to start with the balance equation. barium nitrate, and I know I make barium carbonate and potassium nitrate. So these are going to be a 1-to-1 ratio. So let's do an ICF table using moles. So I have 20 milliliters of 0.2 molar. So that's 0.02 liters times 0.2, which is going to give me 0.004 moles here. And for the barium nitrate, I have 0.03 liters times 0.4, and that is going to give me 0.012 moles. Okay? So because it's a 1-to-1 ratio, I'm going to be limited by the amount of potassium carbonate, and I'm going to have none of this left over and 0.008 of this. Okay? Now the barium carbonate is all going to be solid, so there's no ions that come from this. All the ions are going to come from this. So that's the number of moles. Now we need to decide how many liters we have so we can get molarity, because it's asking about the concentration, which means molarity. So I have 20 milliliters, and I'm going to combine the volume, and I have 30 milliliters for a total of 50 milliliters, which is 0.05 liters. I'm going to cancel out 2 of those, so I'm going to end up with 0.08 over 0.5. Remember this 0.5, it's like saying 0.08 over 1/2, which is the same as 0.08 times 2, so my answer is 0.16. Alright, so we're going to stop right there, and I'll do one more recording.